Hello friends, in this video I'd like to solve the following problem from the Finnish high school mathematics competition final round 1997. It was problem number 1. Find all numbers a for which the equation a times 3 to the power of x plus 3 to the power of minus x equals 3 has a unique real solution x. So my hints for this problem, there are many ways to do it, but I think the most obvious one is to express a as a function of x and then use the methods of mathematical analysis, i.e. limits, derivatives and so on, to plot the graph of function a. And from the graph it should be quite an easy task to see for which a this equation has only one solution. So give it a shot and we will see shortly. Okay, so my attempt, my solution goes like as follows. So first of all, let's take our equation and let's express it as a function of a. So we can write that a equals 3 to the power of minus x times 3 minus 3 to the power minus x. And now let's treat it as a function. A of x equals 3 times 3 to the minus x minus 3 to the power of minus 2x. Okay. Now let's try to graph it, to plot it. First of all, we will consider limits of this function at infinities. So the first limit at minus infinity, let's see, it's just the limit as x goes to minus infinity of 3 to the power minus x, 3 minus 3 to the power minus x. 3 to the minus x goes to infinity, this part goes to infinity, plus infinity, and this part goes to minus infinity. So this limit is minus infinity, while the second limit is limit as x goes to plus infinity, 3 to the minus x, 3 minus 3 to the minus x. Now this part goes to 0 and this part goes to 3. So this limit is 0. Okay, and now let's consider the derivative. The derivative is 3 times 3 to the power minus x times minus natural log of 3 minus 3 to the power minus 2x times minus 2 natural log of 3. Okay, and now let's put 3 to the minus x natural log of 3 in front, and what's remaining is 2 times 3 to the power minus x minus 3. And now let's see what's the sign of derivative. So when is the derivative 0? So a of a prime of x equals 0 if and only if 3 to the power minus x equals 3 over 2. And moreover, a of a prime of x is greater than 0 if and only if 3, so maybe I will write it, x equals minus tertiary logarithm of 3 over 2. And when is our derivative positive? It's pretty easy to see that it happens when x is less than this number. And our derivative is negative if and only if x's are greater than tertiary logarithm of 3/2. Okay, so now we can try to graph, to plot our function. So we know that the limit at -infinity, it was -infinity. So function first goes like that. Then it attains its maximum. Then somewhere is an inflection point, and it goes to its asymptote, horizontal asymptote at 0. So what's one last thing? What's this maximum? Well, maximum happens when x equals minus tertiary logarithm of 3/2 and a at this number. We can put it in our formula for a, sorry. And it was 3 times 3 to the power tertiary logarithm of 3/2 minus 3 to the power 2 times logarithm of 3/2. After a bit of simplification, it becomes 9/2 minus 9/4, and it is 9/4. So we know that the maximum of our function is 9/4, and here we also see that we have only one solution. So from our graph, it can be seen that our equation has only one solution if and only if a is non-positive or when a equals 9/4. So let's write it down. So a equals 3 times 3 to the minus x minus 3 minus to the power minus 2x as a unique solution x exactly when, if and only if and only if a is in the interval -infinity to 0 closed, or when a equals 9/4. And that closes our solution. Thank you for watching. I hope that you learned something, and see you soon. Bye.